Okay, let's go over homework 1.5 number 8. We're talking about the population of bacteria, and it says that it doubles every 3 hours, and we start with 20 bacteria. All right, part A. What is the size of the population after 9 hours? All right, so since it's 9 hours, you can see that every 3 hours, so it's going to actually double 3 times. So you start with 20, so you have 20 to start with. It doubles 3 times. So which means that you're going to have, let's see, 20 times 8, which is 160. Right? So after 9 hours, population of the bacteria grows to 160. All right. Then we're going to look at the size of the population after t hours. All right. So remember that this 3 times can be found by the time 9 hours and divide by 3, because this happens every 3 hours. Alright, so if the time is t, then we can just divide t by 3, then raise 2 to that power. So you can see that you start from 20, and it doubles, and t over 3 times, right? So that's the population after t hours. Alright, then the last problem, we actually skipped the ones in the middle, but so we want to estimate the time for the population to reach 40,000. So we know that a population after t hours would be 20 times 2 to the t over 3. Then we have to set that equal to 40,000. Alright, then let's try to do simplify as much as we can by hand. Then after that we have to use software to find the t value. Alright, so we can divide both sides by 20 at least to make it a little simpler. So divide both sides by 20. Okay, sorry, that's 40,000. One more zero. Alright, so 20 cancel out. Alright, so I can knock out zeros, 1 zeros, and you have 2 and 2. So it's going to be, so this is going to give you 2 to the t over 3 is equal to 2,000. Alright, so we need to solve this. So I'm going to use maxima to find the t value. So I'm going to try to sketch the graph of the left hand side, which is 2 to the t over 3, and graph the constant function 2000, then try to find an intersection. Right, so I'm going to bring up the maxima. Right, so go to plot. Right, so plot 2D. Right, so we want to see 2 to the t over 3. So that's the left hand side, and the right hand side is 2000. Right, then variable is t, and I'm gonna set it to from 0 t to t goes from 0 to something big enough, so I'll try 50. Right, then since we want to see 2000, so I'm gonna make the y max to be 3000 so that we can see the intersection. Right, so then hit OK. Alright, so you can see that you have left hand side, and this is the red one is the right hand side, so intersection is right there. So it's between 30 and 40. So I'm gonna try to find that by using go to equation and find root. Right, so you're gonna have equation 2 to the t over 3. oops, sorry, I have to 2 to the parenthesis, t over 3, then that has to be equal to 2000. Then the variable we're solving for is t, and the lower bound, I think that was between 30 and 40, so I'm gonna just put 30 for the lower bound and 40 for the upper bound. So click OK. Alright, so you can see that the t value came out to be 32.897. So if you take the correct to 2 decimal places, it'll be 32.90. Alright, so we're gonna put that in. So it's gonna take 32 point what was it? 0.90. So 90. So it's gonna take 32.9 hours to reach 40,000 bacteria. Alright, that's it. I hope this was clear.